let us start off electric potential. First, we have to know the language of it. Okay, in the sense we have discussed force, then we have discussed field, then we have discussed potential energy, right?
Yes, sir.
So, actually, in free space, let us say it is a free space. Okay, so in free space, if you place a point charge plus q, we are looking at a
Yes,
very
sir.
general perspective. Okay,
Yes, sir.
there is free space everywhere, 3 dimension, and there I have a point charge plus q. Whenever we have a single charge, the only thing that I can look at is how much charge is there and what is its effect in its surroundings.
Yes, sir.
Clear?
Yes, sir.
Suppose there is a desert and there is one human being in the desert, big desert, and there is one human being. So obviously the first thing that you will automatically focus is, oh, he is alone, or he or she is alone. And the next thing that you will see is the effect of what is going on over there. Are you getting my point?
Yes, sir.
Right? Similarly, or if you look at solar system, you have sun. So first thing is there one sun or is there multiple suns? So we see that there is only one sun. Then we think of what is its effect through the solar system. Similarly, you have a point charge. There is no other charge in the entire 3D space. And what is the effect of this point charge? How much is the charge? The magnitude is q. And what is its effect? In its effect, already we have discussed about electric field, right?
Yes, sir.
So the electric field effect, okay, the electric field is an effect that will tell me how much amount of electrostatic force is possible. Are you getting the point? The definition of electric field is what? You place a test charge over there and find the force acting on the test charge divided by the test charge.
Yes, sir.
So usually I tell the story this way, that long ago there was a king, okay, and that king had a problem. The problem is he was curious, why do things fall? So every day morning when he wakes up, he's in curiosity. Why are things falling? Why are things falling? And to check if every day things are falling or not, every day that fellow used to wake up and tell one person to jump and see if he will fall today. Okay.
Yes, sir.
So he sees every day, okay, people are falling, there is something. Then Newton came and told to that king, relax. You don't have to throw one day, every day, one person. There is something called gravity. And the reason why that fellow is falling is because there is a gravitational force acting on him. Then the king asked, okay, whenever there is a person, there is gravitational force. Then Newton said, no. There is a gravitational field irrespective of if there are persons, no persons, or whatever. So every day you don't have to check it with a person, oh, is there a gravitational force? There is always a gravitational field on surface of Earth. Its magnitude is 9.8.
Yes, sir.
King got wiser. Oh. Then the people in the kingdom also were happy. Thank God this fellow is not testing every day. The idea is that there is an effect due to this charge, and the reason we are studying this effect is to know another physical quantity. So why am I studying field? Is to figure out the force that can act. due to the field. Clear?
Yes, sir.
The
Yes, sir.
next effect that we have is electric potential. And the reason we study this electric potential is to know another physical quantity, which is potential energy. Are you getting my point?
Yes, sir.
The next effect that we have is electric potential. And the reason we are studying electric potential is to know another physical quantity, which is electric potential energy.
Yes, sir.
Clear?
Yes, sir.
The definition of electric potential is simply the electrostatic potential energy divided by the test charge. That means, suppose I have this charge plus Q, okay, and at a distance of R, I want to know the effect of this point charge at this point. Okay, clear?
Sorry. So, like electric field, electric potential also determines how much effect, uh, like,
What is the effect of it? And actually, as we discussed last time, to be very precise, potential is nothing but the ability of this charge at that point.
yes, sir.
You can say it is the effect, or basically, what effect is it telling? The ability of this particular charge.
Like how much of its presence would matter.
Yes. What is the effect of the presence of this particular charge at that point? But what is it leading to? That effect is leading to potential energy.
Sir, then between the field and the potential, like, how can we determine its difference?
That's why I said today we are going to have a conceptual lecture. So field is telling about force. And what is force telling you about? Usually acceleration. And what is
Yes, sir.
acceleration telling about? Velocity and so on. Displacement.
Momentum.
Displacement.
Yes, sir.
Force is a dynamics part of it. Force is the dynamics part of it. In mechanics, actually, we have this. First, we start off with velocity, acceleration, displacement, right? These are called the
Yes.
kinematics of it.
Yes, sir.
The reason why this kinematics is happening is because of the dynamics, which is the force or change in momentum, right?
Yes, sir.
So, the force, when we are studying, we are trying to understand the dynamics part of it.
Yes,
And the
sir.
reason why the dynamics is existing is because energy.
Yes, sir.
The reason why that dynamic is existing is because of energy.
Yes, sir.
Okay. So force is telling you about the motion of the object. Energy is telling you why that force is acting.
Yes, sir.
Okay. We will do the Amir Garib story also today, if we have time. But for now, let me just, focus on the potential and potential energy part. Okay.
Yes, sir.
The electrostatic potential energy, suppose there is a charge plus Q at a point A. Okay. And
Yes.
I have a test charge at point B. I already know that these two charges will have a potential energy. We have already seen that,
Yes, sir.
right?
Yes, sir.
Now, every time to know the energy, just like that mad king, I'll have to place one fellow and throw him to check what energies are acting.
Yes, sir.
Instead of every time throwing someone, I'd rather use a test charge to find out what is the effect of this charge at that point. And this effect is telling the ability of this charge at that point.
Yes, sir.
Clear?
Yes, sir.
That ability is eventually leading us to potential energy only. Okay?
Yes, sir.
Now, if I have a plus q charge at point A and if I place at a distance of r a test charge at point B, right?
Yes,
I
sir.
can say that the potential energy of this system is basically q test charge divided by r, correct?
Yes, sir.
Now, using this definition, what is the definition saying? The electric potential due to a charge can be defined as the potential energy of this system divided by the test charge that is present over there.
Yes, sir.
So, using this definition, if I have to write the electric potential due to this charge plus q, which is at point A, at point B
Yes, sir.
is equal to the potential energy of the system divided by the test charge. Fine?
Yes, sir.
The potential energy of the system divided by test charge, we can just look at it comes out as kq by r.
Sir, but you are taking potential energy at B, which is
Potential
due
energy,
to A.
potential energy is always of the system, not of a point.
Yes, sir.
Potential energy is always of a system, not of a point,
Yes, sir.
right?
So you're taking electric potential due to B.
Electric potential due to A at B.
Sir, so you're bringing A from infinity.
We are bringing
It's that you should bring B from infinity.
that
test
story we used to understand energy. That somebody is bringing something, that means somebody is giving energy to something, right?
Yes, sir.
That story we have used to understand energy part of it. Now
Yes,
that
sir.
now that I have established energy, that if there are two charges, this system has an energy. To know the ability of this charge at that point, I am using this test charge. So now I am not interested in if I am bringing the charge from infinity or not, because I know the energy of this system and I will divide it with the test charge over here, and I will know what? I will know the potential due to this charge at that point. The language is
Yes.
very important. Usually, initially, we will have problem with the language. So what are we finding? Potential due to charge plus q, which is at point A, right?
Yes, sir.
Due to the charge plus q, which is at point A, at a point which is at a distance r. And this
Yes.
potential, how will I write? I will write it as VB, because I am studying the potential of this charge. But where is important? I am studying it at B.
Yes, sir.
See, one important factor in that king story is that if the king used to live in ground floor, there is no problem. Every day one person will come, no problem, sir, I'll jump for you.
Yes.
King lives in the 10th floor. That is the problem. Why I am saying that is, where is important.
Yes, sir.
If he is jumping from ground floor, what is the problem? Jump every day.
Yes, sir.
Where is important. That's why that's the thing I'm saying here when I say language is important, is that the potential due to this at that, due to
Yes, sir.
charge plus q at a distance r away from it, is kq by r. Is it clear?
Yes, sir. So, how much effect of A is there at the point B?
How much effect of A at point B? And if you see over here, we are only mentioning at location here rather than off location. Due to which charge we are not mentioning here. We are only mentioning where I am finding that much only I am specifying in the subscript. VB is equal to KQR.
Yes, sir.
Why I am saying this is, from here on when we use one subscript, that means we are trying to find the potential at that point. Now, due to what? Either the question has to tell us or we have to figure it out by ourselves.
Yes, sir.
But we are talking about the potential at that point, is what this means.
Yes, sir.
Clear?
Yes, sir.
Now, this is the definition part of it. Let us say we have two charges, plus q and plus q, at a distance of 2a from each other. Okay.
Yes, sir.
At midpoint, that means this distance is a. So let's say this point is p, this point is q, and this point is r. Now, if I have to find what is the potential at r, what will I write? I will write 2kq by a. Is this,
Yes, sir.
because it is kq by a due to this charge and kq by a due to this charge. Clear?
Yes, sir.
So when I write VR, what am I writing? I am writing the electrostatic potential at R. Now, due to is not mentioned in the question. We have already understood it. It is because of all the charges which are present in the question.
Yes.
But in the question, if he mentions what is the potential due to P, now I will ask at Q. That means due to this charge at this point. Then I will get it as AQ by what is the
Right.
distance
It
to
will
A.
be 2A.
Is this clear?
Yes, sir.
I cannot write this as VQ is equal to KQ by 2A,
Yes, sir.
because that is,
There's R.
because that will, no, I cannot write
Because
this
it
as,
will include R also. R.
there is no charge at R.
Okay, yes, sir.
No charge. It will include the charge at Q also,
Oh,
not R. If I write it like
okay.
VQ, if I write it like VQ, that means I have to take into account this charge and this charge. Then the answer will be infinity.
Sir, how
Yeah.
do you determine at Q?
At Q due to Q, R tends to 0, A tends to 0.
Okay, okay. Yes,
Same
sir.
we did in electric field also.
Yes, sir.
Is it clear?
Yes, sir.
Same in electric field also we had the same. But here I am specifying this representation part because that is also one of the place where we get confused initially.
Yes, sir.
Okay, if I have two charges or multiple charges or maybe a charge distribution, and if he will only ask you what is the potential at R, sometimes he might only write VR is equal to question mark. That means I want to find the potential at R due to any charge that is present in the question.
Yes, sir.
But sometimes he will ask what is the potential at a point due to this charge. That means there might be multiple charges in the question, but he is asking the potential due to one charge at that point. So we have to take that charge as an independent and not confuse.
Yes, sir.
Clear?
Yes, sir.
Xerox.
So we tell that if force exists, then there is potential, and if potential is there, then there is potential energy. So why aren't we learning this quantity first?
Good question. Actually, I was going to explain it anyways. Either way, I was going to explain it. See, this is the reason I always say that look at things in a very layman perspective. Suppose 10,000 years ago, Stone Age, you see a crow flying. So the first thing that you see is the crow flying, which is motion. What your eyes will identify is motion. Then you will think of why is that motion occurring? Because force is acting. This is now corruption in human brain. If we would have been just like that, oh, there is motion, okay, fine, then there is no problem. But humans have this nature of entering into things. Corruption. So there is a crow flying. Now that's why is crow flying? Flying, leave it. No, I want to know. Because force is there. It is applying force on the wind and wind is applying force on that. And both are playing with each other. Therefore, crow is flying. Now will the human stop here? No. He will say, how is that crow able to apply the force? Because it is eating something and getting energy, therefore it is flying.
Yes, sir.
Because that's the way how humans have developed, therefore that's the way we have in our books also like that.
Yes, sir.
So you are right that we should first start with energy, then understand this energy is creating a force, then understand due to that force there is motion. Okay, so let us say there is an equilateral triangle and I want you to, or I will solve the square and give you the equilateral triangle question. Okay, so let us say we have a square of side A and four charges, each four identical charges of charge Q are placed at the vertices of the equilateral triangle. If O is the center of square, if O is the center of the square, find potential at O. This way of writing means we have to take all the charges, inclusive of all the charges.
Yes, sir.
So I'll just solve this one. Simply what will I do? Because there is symmetry from everywhere, I'll have to find this distance. What is this distance? A by root 2. Correct?
Sir, is it a vector quantity?
No, potential is a scalar quantity.
Yes, sir.
Electric potential is defined as potential energy by test charge. Potential energy is a scalar,
Yes, sir.
so electric potential is
Yes,
also.
sir.
So the distance between the center and the charge is A by root 2, right? Half of diagonal.
Yes, sir.
And there are four charges. And there is no direction associated. So the potential at O is equal to 4 times of due to each charge. Right? So simply
Yes,
the
sir.
answer is 4 root 2 kq by A. Clear?
Yes, sir.
Find the potential. There are three identical charges of each charge q. This is an equilateral triangle of side A. Find the potential at the center. Obviously due to all the charges.
Yes, sir.
We have this as 2:1 ratio, right?
Yes, sir. 2:1.
So basically, total height is a root 3 by 2, and distance is 2/3 of a root 3 by 2.
Yes, sir.
Correct? Clear? So
yes, sir.
So 2 will get cancelled. Simply we will get the distance as a by root 3.
Yes, sir.
If this is a by root 3, automatically this is a by 2 root 3, which we use in our mathematics also. That's why remembering this is important. Right?
Yes, sir.
So the potential at O is 3 times of AQ by a by root 3, which is basically 3 root 3 AQ by B. So let us say we have a pentagon, okay?
Yes, sir.
Let's say we have a pentagon. Basically, we have a polygon of 5 sides, okay? Identical, obviously. So we have a pentagon. Each of side A. Each vertex of this pentagon has a charge of Q. Okay.
Yes, sir.
Find the potential at the center of the pentagon. Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. If I draw a perpendicular and join the center and the vertex, I will get a right angle triangle, correct?
Yes, sir.
For I'm solving this for an n-sided, then we will substitute n as 5. Okay. I'm solving it for n-sided so that you can have it in your notes. What is it for n-sided? Okay.
Yes, sir.
See. So suppose it is an n-sided polygon, n-sided regular polygon. What is this distance going to be? A by 2. Correct?
Yes, sir.
What is this angle going to be? This angle for a
45.
N-sided. So this it is, we just substitute n is 5.
Some theta, sir.
You should not say some.
Theta by 2.
I am telling you. So,
Okay.
So basically, if you join both the points, both the consecutive vertices to the center, how much is the total angle from here to here?
Some theta.
Some theta. Now, clearly listen to this so that whenever you get any question or any doubt in this, you can solve it by yourself in future. Okay?
Yes.
For an n-sided regular polygon, all the sides subtend equal angle at the center.
Yes, sir.
All the sides subtend equal angles at the center. Correct?
Yes, sir.
And if you add all the angles, you should get 2 pi.
360, yes, sir.
That means each isosceles triangle will have 2 pi divided by n.
Yes, sir.
Correct?
Yes,
So this total angle subtended by each will be 2 pi by n.
Yes, sir.
That means half of it will be pi by n.
Yes, sir.
So what is the angle? We should directly be able to figure it out. It is pi by n.
Yes, sir.
Next thing, after this, we will go to trigonometry. In this right angle triangle, sine pi by n is opposite divided by hypotenuse.
Yes, sir.
Let us say hypotenuse is r. What is opposite? It is a by 2 divided by r. Correct?
Yes, sir.
Therefore, what is the hypotenuse? R is equal to A by 2 sine pi by n. Clear?
Yes, sir.
It is difficult or it is not common to remember this all the time. Although as a student you should remember it all the time. But even if you don't remember, you should be able to solve it by
Yes, sir.
because it's an easy thing to figure out. Okay?
Yes, sir.
Now I think you can do it.
Yes, sir.
So the potential at O is equal to 5 times of KQ by distance due to.
Angle is 35.
Yeah, we don't have to substitute, just to put it as pi by 5, that is enough.
Okay, sir.
Angle is 35.
Yes, sir.
Pi by 5 is 35. Maybe I am wrong. 36, right?
36, sir.
Yeah. Fine?
Yes, sir.
So we will have the distance as A divided by 2 times of sine pi by 5. So if that will come up 10 sine pi by 5 times KQ divided by A.
Yes, sir.
Next, 7th question. Suppose I have two charges plus Q and plus Q again. And somewhere along the equatorial line, you know that this is the equatorial line, right?
Yes, sir.
What is the equatorial line? Equatorial line is a line perpendicular to the axial line, right? And passing through the midpoint of these two charges.
Yes, sir.
Or specifically, if we have to say, a line perpendicular to the axial line passing through null point.
Yes, sir.
Right? Because if I make this as plus T 2Q, then again we will have some other equatorial line where it will pass through a null point. To make it easy, I gave it as identical charges. Okay?
Yes, sir.
Let this distance be A. Obviously, that means total distance is actually 2A. Okay?
Yes, sir.
Let us choose a point P, which is at a distance of X from the null point. Okay?
Yes, sir.
Find the potential at point P.
2 times KQ by the hypotenuse. X squared plus A squared
Under root of X squared. Yeah. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.